everybody, Mrs. Bowen here, and we're going to take a look at guided notes for standard 21 and 22, area and parts of figures. And day 3 is going to take a look at circles. So first let's look at the parts of a circle. And here in our figure we have some different lines being labeled. So the first part we'll look at is this line that I have going from the center of my circle to the edge. And this is something called the radius of my circle. And we could say that it connects the center to an edge. So this right here is the radius connecting the center to an edge. And really you could say plural, you have a whole bunch of radii, because you could draw a radius from the center to the edge going all the way around the circle. So you do have a whole bunch of radii, but right here we just drew one. So there would be the radius. The other part of the circle we'll look at is the line that we have cutting all the way through the circle or all the way across the circle. And this is called the diameter. And it connects edge to edge and it goes right through the center. So diameter connects edge to edge and goes through the center. So we can label this as our diameter. Again, the diameter is cutting all the way through the circle, whereas radius is going halfway through the circle. Radius is just going from the center to one edge. We'll use both radius and diameter today in our formulas. And the first formula that we're going to talk about is circumference of a circle. And you can think of circumference as perimeter. So when we looked at other figures, we said for perimeter, you would add up all of the sides in the figure. However, with a circle, we have one continuous distance that goes around the circle. And so we can't add up the sides. Instead, we will use the circumference formula. And when we're dealing with something being round, there's a number that we often use. You may have heard it. It's pi. And pi is 3.1415, etc. It never ends. And we will use pi in our formulas today. That helps us deal with the fact that the circle is round. So our formula for circumference, we're going to use that number pi, and we're also going to use the diameter that cuts across the figure. So circumference is equal to pi times diameter. And our pi is, again, 3.14, and it continues on, but you're going to use the pi button in your calculator. Another way we could write circumference, capital C for circumference, is we could say we're going to do 2 times pi times our radius. So what I did in this formula is I switched out d for diameter with 2 times our radius. And diameter is always going to be 2 times the radius, because radius goes from center to the edge, whereas diameter goes edge to edge going through the center. So diameter is always twice the radius. Let's also make a note about units. So for circumference of a circle, if it's like the perimeter of the circle or the distance around the circle, we just use regular units. You'll remember that from working with the other figures. So we could say it's like feet, meters, inches, etc. But circumference of a circle will just be units. Let's jump into example A. And in example A, it says find the circumference of each circle. And right away I'm given a circle. It tells me R, or radius, equals 3. So I can make a note that if my radius is 3, then my diameter has to be twice that. Diameter is always twice the radius, so my diameter would be 6. And I need to find the circumference. So my circumference is going to be, I'll use this formula, pi times diameter. So I'm going to do pi times 6. And we have an exact answer and a rounded answer. The exact answer will be just using pi, And the rounded answer will be when you type it into your calculator using the pi button, and you'll often get decimals. If we get decimals today, we can round to the nearest tenth. So for my exact answer, we're going to keep pi, but instead of saying pi times 6, I'm going to write it the other way. I'm going to say 6 pi. So the exact answer would be 6 pi units. We don't have units on our figure, so I can just say units, or I could say U. And then for my rounded answer, I need to type 6 times the pi button. And when I do that in my calculator, I will get 18.8 units. And that's my circumference, or the distance going around my circle. If we look at example B, now I'm given my diameter cuts all the way across the figure. So just to note, my diameter is 7. If we wanted to find our radius, to make a note here, my radius is half of my diameter. So my radius would be 3.5. It's asking for circumference, so I can do pi times my diameter of 7. And for my exact answer, again, I'm going to keep pi in my answer, so I could say 7 times pi units. And for my rounded answer, when I type 7 times pi into my calculator, I get 21.99, and it continues on. So when I round that to one decimal place or to the nearest tenths, I actually end up getting 22 units. Let's do one more example before you try a few on your own. So example C. In example C, I'm now given my circumference, and I'm asked to work backwards to find the diameter and the radius. So let's start by writing our formula. Circumference is equal to pi times diameter. And I can fill in what I know. I do know my circumference. That's given to me. It's 18.8 yards. So I can fill that in for my circumference. So I'll have 18.8 equals pi times my diameter. Keep in mind, pi is just a number. So these are not two variables. I only have one variable here. My only variable is d, which represents diameter. Pi is just a number, right? Our calculator can handle that number. So if I'm trying to get my diameter, d, by itself, this is a number pi times diameter. So to undo multiplication, I would have to do division on both sides, and I would divide by pi. So when I do that, I'll get my diameter by itself. We'll get, when we do 18.8 divided by pi, we'll get our diameter. And right here for diameter, it's asking for an exact answer and a rounded answer. So there's two parts for diameter. My exact answer, I can just write it here. We were doing 18.8 divided by pi. So I can leave the pi for my exact answer. So I'll have 18.8 divided by pi, and my units were yards. And then for the rounded answer here, I'll type 18.8 divided by pi. And when I do that, I get 6 yards. Now that I did diameter, I'm also asked to find the radius. And for the radius, I need to take half of these numbers, right? Diameter is always twice my radius. So basically, I need to take these numbers and cut them in half. So if I do 18.8 divided by 2, I get 9.4. So 9.4 divided by pi yards for my exact answer for radius. And then my rounded answer, we're doing half of 6 or 3 yards. All right, at this time you tries 1, 2, and 3. Go ahead, pause the video and see what you come up with. Let's see how you did. On you try 1, my radius was 8, my diameter was 16. My exact answer was 16 pi feet. My rounded answer was 50.3 feet. On you try 2, my diameter was 18, my radius was 9. My exact answer for circumference was 18 pi feet. My rounded answer was 56.5 feet. And then for you try 3, I was working backwards. I was given that my circumference was 25.1, and I had to work backwards to find my diameter, so I divided by pi on both sides. For my exact answer, I get 25.1 divided by pi yards. My rounded answer is 8 yards. And then once I knew my diameter, I could cut it in half to find my radius. So my radius exact answer was 12.55 divided by pi yards, and my rounded answer was 4 yards. If we check out the back side of our notes, we are now going to talk about area of a circle. So we talked about circumference of a circle, meaning the distance around the circle. And now area of a circle is, again, the flat space that's inside, that takes up the inside of the circle. So for area of a circle, we do have a new formula, and we will still use pi, that number that we use to deal with circles. And so it's going to be pi times our radius squared. So this is radius raised to the second power. Let's also talk about units for a circle. Just like area with the other figures we worked with, area is units squared. So it could be like feet squared or meters squared, but it's always going to be square units. And let's take a look at example D. So in example D, we're now finding area. And we can make a note. It's always good to notice what's your radius, what's your diameter. It's good practice. So my radius here is 6. That means my diameter is twice my radius, or it's 12. And I'm asked to find area. So I'll do pi times my radius of 6 squared. Keep in mind, pi is just a number. If we want to give an exact answer, that means we want to keep pi, because again, pi is a number, it's got a long decimal, it does not end. So let's take care of this 6 squared. We can easily do that. 6 squared is 36. So we would have 36 pi, and then our units would be square feet. That'd be an exact answer. And a rounded answer would be if we type 36 pi into our calculator, or up here with our original area formula, we could just type pi times 6 squared, either way. And when we do that, we would get 113.1 square feet for my area. On example E, I'm now given my diameter. So we can make a note here, diameter is 18. So that means our radius has to be half of that, or our radius is 9. So for area, we're doing pi times our radius of 9 squared. Exact answer, let's keep pi in it, but we can simplify this 9 squared, or 9 times 9, to get 81 pi. We'll have square feet as our units. And rounded answer, I can either type 81 pi into my calculator, or using my original formula, I could do pi times 9 squared. When I do that, I'll get 254.5 square feet. And then example F is going to be one where we work backwards. So you'll notice now I'm not given a circle with the radius or the diameter given to me. Now I'm given area. So let's start by writing our formula. Area equals pi times radius squared. And then we can plug in what we know. We know our area, right? Our area is given to us. So let's plug that in for A. So I'll have 16 pi equal to pi r squared. Now I need to solve this equation, and I only have one variable. My variable is r. I'm trying to find my radius here. And pi is just a number. So first thing I could do is I could get rid of this number that we have in front of our radius squared. So I could divide by pi on both sides. And when we do that, you'll see the pi ends up just dropping out of the problem. I'm left with 16 equals my radius squared. So now I need to undo something being raised to the second power. And then we talked about the way you can undo that is by taking the square root. So by taking the square root, you cancel out, or you undo the second power. Whatever I do to one side of the equation, I must also do to the other side. So then I'm left with a radius of square root of 16 is 4. And so in this case, my exact and rounded answer end up being the same. I get 4 feet for both for my radius. All right, so now you tries 4 through 6. Go ahead and pause the video. On U try 4, my radius was 8, diameter was 16, exact answer 64 pi square feet, rounded answer 201.1 square feet. On U try 5, diameter was 22, radius was 11, exact answer 121 pi square inches, rounded answer 380.1 square inches. And then U try 6, I was working backwards to find my radius. And for both my exact and rounded answer, I got 8 meters for my radius. We have one last example, example G. And example G is using a lot of the information that we've learned for area of figures. It asks us to find the area of the shaded region. And you'll notice here that the shaded region is really the region between my outside figure, which is a circle, and the inside figure, which is a triangle. So this means I'm actually going to have to find 2 separate areas. I'll have to find the area of the circle and the area of the triangle. And I need to know the difference, or I need to subtract them in order to find the shaded region or the shaded area between them. So let's start with the circle that we see. If I'm looking here at the circle, I can make a note that for this circle, I'm noticing that 10 is the diameter. It's cutting all the way across the circle. So for my circle, my diameter is 10, which means my radius is 5. And so this will help me to find the area of the circle. So I'm going to say capital A, and then I'm going to use a little circle. So area of the circle, and we need to remember our area formula for a circle. We do pi times radius squared. I know my radius. We said my radius for the circle is 5. So I'm doing pi times 5 squared. And I can just plug that in my calculator, and I can go ahead and get a rounded answer. That's fine. So when I do pi times 5 squared, I end up getting 78.5. I'm just going to say units squared. That's my area of the outside circle. Now let's find the area of the inside triangle. So I'll say area of the triangle equals, and we need to recall the area formula that we used for area of a triangle. For area of a triangle, our formula was 1/2 base times height. And recall that in a triangle, your base and your height are the 2 sides that form this right angle. So my base and my height would be these 2 sides, 6 and 8. So I'm doing 1/2 times 6 times 8. And when I do 1/2 times 6 times 8, I get 24 units squared. So now I found both areas, and we said we just want the shaded region. So that's the area that's between the circle and the triangle. So I could say that area of the shaded region is equal to area of the circle minus area of the triangle. This is me just trying to make a note. Area of the shaded region is area of the circle minus area of the triangle. So now I can plug in those values. So area of my shaded region, the area of the circle was 78.5. My area of the triangle was 24. And so for my final answer here, I'll get 54.5, we'll say square units. And that would be my area of the shaded region, the area between the circle and the triangle. So if you look here, you try 7 and 8 are similar in that you're going to have to find multiple areas. If you look here, you have a circle and maybe a square. And so you have to find multiple areas, subtract them in order to find the area of the shaded region. So take a few minutes, see what you can come up with for you try 7 and 8. Go ahead and pause the video. All right, so in you try 7, I first found the area of my outside figure, which was a square. And if you recall, area of a square is side length squared. Our side length was 10, or 10 by 10. So we did 10 squared to get 100 square units for area of a square. Then I found area of my inside figure, which was the circle. So we were doing pi r squared. My radius here was 5. So I did pi times 5 squared, and I got 78.5 square units. So then the area of the shaded region was the area between the square and the circle. So I was subtracting area of the square minus area of the circle, and I got 21.5 square units. On U-Try 8, this was the most challenging one because I'm given a square. So actually my area of the square ended up being the same. It was a 10 by 10 square. It ended up being 100 square units. But for area of the circle, I had to be careful. I don't just have one large circle, I have 4 circles. And so if we're finding area of one circle, we need to know the diameter. And if it's 10 units all the way across this square, that means it's 10 units all the way across 2 circles. So if we cut 10 in half, that means that this circle would have a diameter going edge to edge and through the center of 5. And this circle would have a diameter going edge to edge and through the center of 5. So I'm just going to find area of one circle. So let's just say I'm looking at this first circle here. I would do pi times my radius squared. And if my diameter we said for this first circle is 5, we need to cut that in half to get my radius of 2.5. So I would do pi times 2.5 squared to get 19.6 square units. And that's just for one circle. But I made a note here, we don't have one circle, we have 4 circles. So I took this 19.6 and I multiplied it by 4 because we have 4 circles. And once I times it by 4, then I said area of circles plural is 78.4 square units. So then lastly, area of my shaded region is area of the square minus the area that I found for the 4 circles. And I ended up getting 21.6 square units.